Okay, next up, we're going to look into setting up and running the design rules check. First, we'll start with configuring the display of rule violations. CircuitStudio has two techniques for displaying design rule violations, each with their own advantages. These are configured in the PCB editor DRC violations display page of the preferences dialog. You have the violation overlay. Violations are defined by the primitive in error being highlighted in the color chosen for the DRC error markers, which is configured in the view configurations dialog. The default behavior is to show the primitives in a solid color when zoomed out. Change to the selected violation overlay style as you zoom in. The default is style B, just a circle with a cross in it. There are also the violation details. As you zoom further in, violation detail is added if it's enabled, detailing the nature of the error, and we use the show violation detail slider to define what zoom level the violation details start to display. We're going to go ahead and enable the required display options here within the preferences dialog. So first of all, let's go ahead and go into our view configurations dialog. Again, we're just going to click on the color box down here below. And we just want to make sure that the DRC detail markers and DRC error markers are both enabled. We want to confirm that the online DRC is actually enabled. This is in the system preferences under the PCB general page. And then we're going to go back over to the DRC violations display page. And again, this is where we configure how violations are displayed in the workspace. And there are two different methods available for displaying violations, each with their own strengths. Now for the tutorial, we're going to right-click in the display area of the PCB editor DRC violations display page. And we want to select Show Violation Details Used. And we want to right-click again and Show Violations Overlay Used. And we are now ready to check the design for errors. The design is checked for violations by running the design rule checker. Click on the design rule check button on the home tab of the ribbon to open the dialog. Both online and batch are configured in this dialog. Now this section will not have defined exercise steps, but you should be able to follow along with me or read through the provided documentation to kind of glean the steps that you're going to need to take from within the discussion. So within the dialog here, you have your DRC report options. By default, the dialog opens showing the report options page selected in the tree on the left. And on the right side of the dialog displays a list of general reporting options. These will be left at their defaults. We also have the rules to check. The testing of specific rules is configured under the rules to check section of this dialog. Select this page in the tree on the left of the dialog to list all the rule types. They'll be shown below. You can examine them by type. For example, if we only want to look at the electrical, we can click on electrical here. And if we want to see them all again, we click on the rules to check to show all rule categories. For most rule types, there are checkboxes for online to check as you work, and batch for when we actually run the design rule check, which is done from the button down here below. We click to enable or disable the rules as required. Alternatively, we can right-click to display the context menu, and this allows you to quickly toggle the online and batch settings. We're going to do the batch DRC used on entry. And then once we have this set up the way that we want, we're going to go ahead and press the Run Design Rule Check button. When the Design Rule Check button at the bottom of the dialog is clicked, the DRC will run. The Messages panel will appear listing all detected errors. If the Create Report File option was enabled, in the Report Options page of the dialog, a Design Rule Verification report will open in a separate document tab. And below the summary of violating rules will be specific details about each violation. The links in the report are live. Click on an error to jump back to the board and examine that error on the board. And note that the zoom level for this click action is configured in the System General Settings page of the Preferences dialog. And you can experiment with this to find a zoom level that suits you. Just to see the difference there, click on that and we can now see that it zooms in a bit closer. Next, we'll look into identifying violations and then into resolving violations. Next up, we're going to look at identifying error conditions. When you are new to the software, a long list of violations can initially seem overwhelming. A good approach to managing this is to disable and enable rules in the Design Rule Check dialog at different stages of the design process. It is not advisable to disable the design rules themselves, just the checking of them. For example, you would always disable the unrouted net check until the board is fully routed. When a batch DRC is run on the tutorial board, there are 16 total violations, which means the measured values are less than the minimum amount specified in the applicable design rules. You now know how to locate those violations by clicking on the link in the report file or double-clicking in the Messages panel, and using the violation details, we can understand the error condition. If we go ahead and zoom in here, we can see the violation details for one of the clearance constraint errors indicated by the white arrows and the 0.25 millimeter text. The next step is to work out what the actual value is so you know how much it has failed by. Apart from actually measuring the distance, there are two approaches to working out how much the rule has failed by. Either by using the right-click Violations submenu, or we can access the PCB Rules and Violations panel. The right-click Violations submenu is accessed by right-clicking on an item marked with a violation and accessing violations from the right-click menu. If we click on an individual item here, the violation details will appear. The second approach to understanding the error condition is to use the PCB Rules and Violations panel. To access this, go to View, and then in the PCB section, you can access the Rules and Violations button to display the panel here, or as we saw under the Home tab in the Design Rules section, we can also click on the Rules and Violations button here to display the panel. If we find any violation here and click once on a violation, we will jump to that violation. And if we double click, we will open the Violation Details dialog. And using this information, we can very quickly navigate through our design to find the various violations that need to be resolved and either modify the rules or modify the board. And so next we'll look at resolving these violations so that we have a board that is error-free. Okay, so we've learned how to set up and run the design rule check and how to interrogate and investigate violations. Now we need to look at resolving the violations. First, we'll look at the electrical clearance, and as with the previous sections, there are no real defined exercise steps here, but you will want to follow along with what I'm doing and go ahead and complete these same steps in your design. Either do this along with me or watch the videos and retrace the steps within the documentation that is provided with it. There's a lot to show and tell here, mixed in with a few changes we need to make. So to make it easier to read, the exercise is not split out into its own section here. As the designer, you have to work out the most appropriate way of resolving each design rule violation. There are two ways of resolving the clearance constraint between the pads in Q1 and Q2. We can either decrease the size of the transistor footprint pads to increase the clearance between the pads, or we can configure the rules to allow a smaller clearance between the transistor footprint pads. Since the 0.255 millimeter clearance is quite generous and the actual clearance is quite close to this value, just a 0.22 millimeter, a good choice in this situation would be to configure the rules to allow a smaller clearance. This can be done in the existing clearance constraint design rule. As a reminder, the design rules are configured in the PCB rules and constraints editor dialog, which is under the Home tab. In the design rules section, we click on the design rules button, and we're going to go ahead and click into the clearance rule so that we can edit it. And we're going to go ahead and scroll down into the grid here and find the cross section for through-hole pad to through-hole pad. We're going to change that value to 0.22 millimeter. To edit the cell, simply click in it and press F2 to open the cell for editing, or click into it once and then a second time to open it for editing. Now in this particular case, this solution is acceptable because only other component with through-hole pads is the connector, which has pads spaced over 1 millimeter apart. Next, we're going to take a look at the minimum solder mask sliver violations. To resolve these, we can either adjust the solder mask expansion rule to decrease the automatic solder opening for your pads to be a smaller value, or we can adjust the minimum solder mask value, or both. For this particular situation, let's make some minor modifications to both and enter some more sensible metric values into these rules. Open the mask category within the design rules dialog. Go ahead and close these up. And we want to select the solder mask expansion rule, and we're going to change the value here from 0.102 to 0.08. This will reduce the solder opening for all component pads following the rule, which in turn will increase the width of the sliver created between two pads. If we interrogate the minimum solder mask violation after the expansion is changed, we will see it is still in violation, and that there is a sliver that is the size of 0.017 millimeter. So we'll change the minimum solder mask sliver to match this and clear the violation. The values used here are not necessarily indicative of what is manufacturable. It is always best to check with your fab house to find out which values you should use to check your design for manufacturability concerns, such as solder bridging. The default value of this rule is 10 mils. This is in the manufacturing category, which converts to 0.254 millimeters and is likely much larger than what we need. So we're going to change the minimum solder mask value to 0.06. And then we're going to go ahead and rerun the design rule check. And with the changes we have made so far, we should only have some silk to solder mask clearance violations left to review and resolve. Again, the default value for this rule is higher than we need. And in this particular case, I just want to make sure my silk is a short distance away from any solder mask openings, as I do not want silk screen being printed on top of my pad copper, causing soldering issues. So we want a bit of space, but we really do not need too much. So we're going to go back into the design rules, and we're going to look at the silk to solder mask clearance. Again, default of 0.254. We're going to change this to 0.1, and then go ahead and click OK. Go ahead and rerun our design rule check just to be sure. And we are now violation free. So with that done, let's go ahead and go back to the PCB and perform a file save all, and we will continue on to generating our final outputs.